Hello, good morning, everyone, and welcome to the Bow Valley Sustainable Building Summit. My name is Jody Connuel, and I'm a program coordinator at the Biosphere Institute of the Bow Valley, and I will be your host today. Before we get started, I just want to go over a few housekeeping notices. As webinar attendees, you will not be able to unmute your microphone without permission or turn on your video. However, as always, we welcome active participation at these events. So if you have any questions for Frank as he goes through his presentation, please do type them in the Q&A box, which you can find at the bottom of your screen. He's going to spend some time discussing your questions and giving some answers at the end of his presentation. If you experience any technical difficulties, please do message me privately using the chat function, and I will do my best to assist you. The Bow Valley Sustainable Building Summit has been brought to you today by the Biosphere Institute of the Bow Valley and the Bow Valley Builders and Developers Association. The Biosphere Institute is a local Canmore-based charity that aims to address what we believe are the two major challenges affecting the Bow Valley today: human-wildlife coexistence and climate change. We do this through targeted education, research, and community engagement, and our climate action efforts are managed under the Bow Valley Shift program. The Bow Valley Builders and Developers Association, otherwise known as BODA, is a membership-driven networking and advocacy group. BODA keeps its members up to date on issues impacting the industry and our local community. BODA luncheons have become the premier monthly business networking event here in the Bow Valley. With funding from Energy Efficiency Alberta and the town of Canmore, the Biosphere Institute spent 6 months in 2019 asking local businesses what they wanted to learn about energy efficiency and how they wanted to learn it. The result was the Bow Valley Sustainable Building Summit, and unfortunately, due to COVID-19 pandemic, the decision was made to cancel the original in-person event, but then we decided to take it online, and that's how we got here today. So without further ado, I'm going to introduce today's presenter, Frank Kernick. Frank was born and raised here in the town of Canmore on the site of Spring Creek Mountain Village. Frank Kernick is the developer of this property, which has been in his family since 1927. Frank graduated from the University of Calgary with a Bachelor's of Science in Mechanical Engineering back in 1985. After working in Calgary for several years, Frank made the decision to move back to his hometown. He has been an active member of the Canmore community ever since. His professional background is in engineering and land development, and he has extensive development experience in mountain communities in particular. So I'm going to hand the presentation over to the man you came here to see today, Frank Kernick. Please take it away.
Thanks, Jody. I guess I should start with screen sharing.
Yes, please.
Forgive me, everyone. I'm trying to still figure out this technology. Welcome, everyone. I'd like to thank Jody and obviously everyone else at the Biosphere for putting these seminars on, as well as BODA for helping to sponsor this and all the other sponsors, the town of Canmore and so forth. They did ask me to talk about geothermal or GeoExchange, as I've been playing in this industry, I guess, with my developments for about 15 years. So the first thing I'm going to do is maybe just give you a little brief what we're going to be reviewing today, or what I plan to review today. Now I got to figure this out again, Jody. The little arrows. Sorry, everyone. Going to do a brief introduction, obviously, as we're going to start with right away. After that, I want to go over what is geothermal and what is the difference between GeoExchange. The basic components of a GeoExchange system, the energy value of GeoExchange and other sources of heating and cooling, and GeoExchange and how we use it in Spring Creek. It's quite unique here, and why we're using it extensively in Spring Creek. Then one of the last things will be GeoExchange and a net zero example that was provided by another company for me that I haven't done myself, but it's interesting information. Then we'll go to questions. So while we're going through this presentation, if you can, as Jody said, send your questions and we'll try and deal with those at the end. I'm not an expert in geothermal or GeoExchange. I do use it in my developments. I am a mechanical engineer, so I do have a little bit of background in that. So if things aren't perfect, please forgive me at the beginning. And if you do have questions, please, I'll try and answer them best I can. If not, we'll try and get back to you with those answers at a later date. With that, I've asked Jody if she could do a little poll for us, just so I know who is my audience today. So if Jody, if you can do that for me, would be wonderful.
Sure. Okay, everyone, we expect 100% participation. I'm going to launch this poll. We just want to find out a little bit about who you are and who we have on the line today. So if you just take a moment just to select a suitable catalog for you and what kind of projects you work on and what experience you have here with geothermal systems. We're probably going to keep this up for about a minute, so you've got plenty of time to answer. Okay, we got about 20 seconds left. We got about 50% voted. Oh, 60%, doing well. Keep it up. Okay, we're going to give you 10 more seconds. And I think we got a pretty good coverage there, so I'm going to end the poll. And I'm going to share the results with everyone. Okay, so we should see we've got quite a good range of students on the line today. Some superheroes, and lots of people with no experience in geothermal.
Wonderful.
Okay.
You want me to take it from there, Jody?
Yeah, please go ahead. Hopefully that helps you with your presentation, Frank.
That's a lot. Thank you. Yeah, so let's start this off by first giving you a little introduction to myself. A lot of that was in my bio already. As you know, I'm an engineer and I was born and raised in Kamloops and didn't know what an engineer really did when I went to school, and ended up working in making aluminum beer cans for 5 years with Crown Cork and Seal. And then ended up coming back into Kamloops in 1990 and sort of fell into land development. Being unemployed, sometimes that's the best thing. You look for things that are opportunities out there. And with another friend, we started a small residential subdivision around 1991. Did a couple other residential manufactured housing subdivision, and then a large subdivision in Kamloops called Eagle Terrace back in the mid to late 90s. I did buy some land in Invermere back around 2000, and that was where I delved first into geothermal. And with that, I built a development called Lakeview Meadows. And when I was building that development, propane went skyrocketed in price back in the early 2000s. So did natural gas. I think it went up to one time $12 a gigajoule. Now we're $2 or $3. But the costs in that rec center were extraordinary and just killing my property owners association that I built for the community there. My first project really was taking a renovation onto the rec center, and we added geothermal as a horizontal ground loop. We had land in the back where we could, where a field was for the community center that we could build horizontal field, and added geothermal onto the building. And it really reduced our operating costs on the building. It's still there today. It still runs geothermal, or Geo Exchange. After that, I built my own single family home there, a large home there, and I did the same thing, did a horizontal field. And I've had that home there since 2005 and been running geothermal for both heating and air conditioning in that building. I continued to play, and I did a 50 unit or 26 unit condo building in Invermere called Copperside. In that building, we did 50 vertical wells in the parkade. We didn't have the land, and it was a question of where do we put these wells to make this work. So we drilled it in the parkade. There are 50 wells, 200 feet deep, and provides both heating and air conditioning to that condo building in Invermere as well. Around 2002, I bought the land off the family, Spring Creek Mountain Village. It was my grandfather's dairy farm. My father and uncle had made it into a trailer park campground. That's what I grew up doing, putting water sewer lines in and cutting grass. And my father and uncle were in 2002, were quite elderly. They're in their late 70s, mid to late 70s. And I was running out of land to build things in Canmore, so they convinced me to buy it off the family, which I'm glad I did. They had it up for sale and had 10 great offers on it, and I paid them the highest price, and because I didn't want conflict with the family, and started my rezoning and my future. What is it going to be? And I tell everyone that Spring Creek is my legacy project, because it is. It's been in the family since 1927, and it's important to do it right. But also with the redevelopment of Spring Creek, there's the social side and environmental side that are both very important in Canmore. I had to take into context. And one thing with my background of geothermal and GeoExchange, I really wanted to try and implement that into Spring Creek. For one reason, mainly too, it made it more cost effective, was we have such a strong aquifer in Canmore. We 200 feet of gravels below us that are full of water. You dig down on Spring Creek more 5-6 feet, you'll hit the water table at high water times of the year. So we had this strong aquifer of water, and that really made sense for using Geo Exchange and geothermal in Spring Creek. I'll talk a little bit more about that later, but that's a little introduction of how I ended up in doing Geo Exchange in my lifetime. The real question we always debate is, what is geothermal and what is GeoExchange? And the reality is, we call it geothermal. I've been calling what I've been doing geothermal for years, and a lot of people, we all still describe it as that. But the reality of geothermal is really, a lot of countries, they do extract steam or heat out of the Earth's core or surface mantle and bring that to the surface to run electrical generation, heat buildings. That's true geothermal from what I believe we're doing, and that is more GeoExchange. So when geothermal, when heat rises from the core near the surface, it can be used, as it says in the description, to heat buildings and run electrical generation. What we really do, though, is more GeoExchange. Excuse me one sec. Heat is stored, the sun heats up the Earth's surface. This energy and heat is stored in the relative shallow layers of the Earth's surface. At wintertime, even in Canada, sure, we have frost 4 or 5 feet down, but below that, the ground is above zero, and you get down deeper than that 4 or 5 feet, it stabilizes, around in Canmore here anyways, around the 7 to 10 degrees Celsius. So, the Earth is absorbing all this energy from the sun. And as you read there, the sun's energy provides over 500 times the amount of energy that we really need to heat and cool our residence in our building. This is GeoExchange, because you're actually taking the heat at lower temperatures, run it through a heat pump. The heat pump brings it up to the temperature you need, or drops it down to the temperature you need for cooling, and delivers this heat and cooling through a delivery system through the house. That is really GeoExchange. It's not just using the raw heat from geothermal. It is actually using a heat pump, which I'll describe later if you're not sure what a heat pump is. Why is this important? It's important to get renewable HVAC for all buildings if we really want to reduce greenhouse gas emissions, and we want to save energy and energy costs. As you see in both residential and commercial buildings, your heating, cooling, your hot water provided for these buildings are really a substantial part of the energy that we use in our buildings is for your HVAC systems. So, how can we reduce costs and reduce CO2 gas emissions? Well, the more we can reduce the energy inputs for heating, cooling, and hot water, the more we can reduce costs and also reduce CO2. So in our built environment, accounts for about 33% of the energy consumption in Canada. So, this is really one of the areas that we can tackle, and we all live in a house, and we all are home, and we all need to long-term, for the sake of the earth, reduce that consumption. What are the basic components of a GeoExchange system? Well, there's a field, and generally this is either most commonly a horizontal or vertical field that you have to build to be able to do that exchange of energy. We use in Spring Creek, as I mentioned, an open loop system because we have an aquifer, and I'll show you that a little later. The next part of the system, once you have your field, is your heat pumps, and that there's different types that you can use depending on how you want to distribute that energy, the heat and cooling through the house. Forced air, a hydronic one, which is water-based, or a combination of both. So you do need that heat pump to bring the up to temperature and show that amount. And of course, the distribution network that we have, again, either through ductwork or infrared heating, to be able to distribute that heat and that cooling. And of course, as any system, whether it's we need our controls. So the distribution, the controls are the same, whether it's a Geo Exchange or whether it's a house with just a regular forced air furnace or boiler system. The distribution really doesn't change. It's really the front end of the system that we are using for the Geo Exchange. How does it work? That's the biggest question. I like to explain to people when they ask me about it. I describe it. It is a refrigeration cycle. It's the same way your refrigerator works in your house. How is it? Why is it cold inside your refrigerator, and why is it hot at the back of your refrigerator? That's because we are using a refrigeration cycle to bring the temperatures up to what temperature we would require. And we do that by compression our gas. It used to be Freon years ago. It's very many different gases now that are way safer. You compress that gas and it creates heat, and that heat then you distribute through pipes to your fan coil or through in-slab heat. In my big buildings or geothermal heat pumps, take the hot temperature, usually it's 110, 120, and put it into a distribution tank. From the tank there, it's just distributed throughout the building. But you can directly have GeoExchange units that have their built-in fans that can blow the hot air into the house. And from there, we have this evaporator where we expand the gas, and we have to get that warm water from the field that's maybe 7 to 10 degrees. And we usually take 3 or 4 degrees delta T out of that warm water, and the water goes back, fluid back to the field at, usually 3 or 4 degrees less temperature. It gets reheated by the ground. That's why it's GeoExchange. It comes back at that 7, 10 degrees again, and the cycle continues. That's in heating mode. In cooling mode, it's really just reversing the cycle, where the coolant is reversing the flow. So we are basically taking blowing cold air and reversing the cycle that we're sending warmer water to the field and returning back. That is returned back. It might go out to the field at 12 degrees and come back again at that 7 to 10 degrees. So we're just really reversing the cycle. And that's the beauty of the refrigeration cycle. And this also is the same for an air source heat pump. That is something that is very comparable to GeoExchange, but it has its disadvantages, but less cost. And it's also a very valuable thing to use an air source heat pump. I'll show you that in a little later. But both are used in the refrigeration cycle to create to bring our heating up to 110 degrees or cooling down to maybe 40 degrees Fahrenheit, maybe where you want to blow the cold air over your fan to give it cooling in your house or home. Or in other industries, we use that as well. And the nice thing about this in big buildings or different facilities is that you can run simultaneously heating and cooling. And some of my large buildings will be calling for cooling loads on one side of the building because it faces south. Well, the north side of the building is calling for heating. And by running our heat pump, we can feed both tanks and to cool our cold water tank or heat up our hot water tank, depending on what the requirement is. And then any excess heat or cold can be sent to the field through a 3-way valve. So that's another beauty of GeoExchange, is that we're able to do both at the same time. So for instance, we're running air conditioning in the summer. We can also take the heat that's generated, instead of send it to the field, we can send it to a preheat tank for our hot water. So yeah, you want your hot water 160, but we can preheat the water coming in from the street up to the 110 degrees while the air conditioning is running. And then the 110-degree water can go and be taken up to the appropriate temperature you need for hot water for the house. So there's major advantages of GeoExchange and running those heat pumps simultaneously, or using the system simultaneously, that we're not wasting that heat on air conditioning mode when we can use it to heat up our hot water or heat up the other side of the building that might be cold. And we use that in all my major buildings as making it more efficient. So what did you use heat pumps? There's 3 different types. As I said, you got your commercial water to water. It says up to 70 tons, but we are using larger ones now. This is old. We're using in my next building. We're using 2 81-ton heat pumps, and I think they can produce 1 million BTUs each. And we use water to water my buildings because, like I said, we distribute the slab heat, which these are perfect for slab heat, for in-floor heat, because the water is at 110 degrees. For our quarter pressurization zones, we do have to have bigger fan coils than we would if we were running 160 water, but it's more energy efficient using the geothermal as much as we can. You can have forced air geothermal units that, again, same thing, they run a compressor and they blow the air right directly into your ducts. Or we can have a combination where it has forced air, but also you have hydronic heating maybe for in slab and for some of the units. So there's multiple ways of GeoExchange heat pumps that you can have, and that's the versatility of the GeoExchange as well. Common loop field designs, the very most common one probably is the vertical closed loop. Generally, you drill down 200 to 400 feet. As I said, my apartment building, we did 50 boreholes. Very costly. And this is where people go, GeoExchange is costly. Yes, if you have to go to the extent to drill, for generally a single family home, it's a couple boreholes. But like for my 26 unit one, we had to do 50 boreholes. So there's a major capital cost to drill, and all depends on the geology too. Granite, to be honest with you, better to drill through than gravel because it doesn't cave in. You don't need a case. So there's cost of casing, cost of filling, putting the circulation loops down, creating the field. It's quite costly to do, and probably one of the least cost effectives. The horizontal loop, closed loop trenches, that's what I did in my house in Tamerack in the rec center. That worked very well for me. I had the land for it. We had a big hole there. We just dug a big hole 10 feet down. We did our horizontal loops. We filled it 3 feet of fill on top of that, and did another horizontal loop at 7 feet, and then brought those pipes into the building. So it was basically the cost of the machine. It was silts there, so I didn't have to bed it in with sand. It was very efficient for me to do there. Is the cost of the machine for a few days, plus the cost of the plastic loops to bring it into my house, into the rec center. But the most efficient for me in Spring Creek here is, like I said, was the open loop, because we have such a strong aquifer. The issue was when I did that in 2006, there was a moratorium on water wells in Alberta, and we weren't. I built my first building with it in, and then when I drilled my wells, I went to register with Alberta Environment, and they said, no, you can't. We're not giving out any more water wells. And I said, well, I'm not using water. We're just taking the energy out of the Earth's surface. We're taking 3 to 4 delta T out of the water and putting it right back in at 70 feet. We're not using water. This was a real hurdle. It took me hundreds of thousands of dollars over the last 10 years to get Alberta Environment with policies in place that are reasonable for monitoring and showing that this is a viable system. It is so new in Alberta. Over in Europe, this is done everywhere, but we are such a gas-oriented province. Even to get Alberta Environment to consider this was hard, and it was a challenge, and we finally did. But over the last 10 years, to get reasonable monitoring requirements has been the biggest challenge. In the last year, I have to admit, they finally seem to be coming to things that are reasonable. I still have to do yearly reporting and monitor weekly the amount of water we use. Do I have groundwater levels so when we're not affecting groundwater because we're not using any water? That's been my biggest challenge is Alberta Environment, surprisingly, who should be supporting sustainable development, not holding it up. But it works excellent here in Spring Creek because we're so close to the water table. And then the last one is pool loop. If you have an acreage or farm and you had your pond up back, you can get these loops and throw them into the lake. Even though you might get ice on the top 2-3 feet, the loop underneath water will still be over the freezing temperature. And those can be in the bottom of the lake, and you trench it into your house, a very efficient, cost-effective way as well for our loop designs. So that's the biggest differential in cost, is probably your loops and who can do that, and it depends on the land and where you have. So that's GeoExchange, the basic design. I want to get into a little bit the energy value of GeoExchange, because compared to other forms of energy that we do use, you know what I mean, first you got to understand what energy value is. And it's really, we talk about the efficiencies for heating and cooling appliances, how they relate and how efficient they are in converting utility energy. And obviously a lot of this usually is non-renewable, natural gas, electricity that, you know, in Alberta is dirty electricity. A lot of it is coal-fired electricity, some gas, some sustainable. You know, but how efficiently are we converting whatever energy we're using for heating and cooling energy output in our BTUs? Higher efficiency means more BTU output for the same energy input. So that's why we always try to find higher efficiency boilers, furnaces, and obviously means lower utility costs. Efficiency is often a percentage, so we think a 90% efficient furnace. You know, we're all trying to get more condensing furnaces, boilers that are more energy efficient. In the heat pump industry, we use COP, coefficient of performance. And I'll show you how this all relates. For instance, coefficient of performance is a percentage of the 100%. So a furnace would be 90% efficient, is a COP of 0.9 for our standard gas appliance for a forced air furnace. So how does this work, the energy value of GeoExchange? Well, you know, the green line down there is our loop, our field, where we have that renewable energy, where we take the cold fluid and we reheat it back to our normal ground temperature. We compress that to whatever temperature we generally require, generally 110 degrees Fahrenheit, and then we use that warmth and we blow that into our building. We generally use electricity to drive, or we are using electricity to work that compressor. And generally, you know, for heat pumps, generally we end up with a coefficient of 4, that for every unit of energy we put into the system, we get 4 units of energy out. So generally we are reducing our energy consumption if it compared to electricity by 80% for heating and cooling, if we're using strict electricity, because electricity is resistant coils is what we call coefficient of performance of 1. It's basically what you compare everything to, because for 1 unit of electricity, you get 100% heat out of that. Gas furnace, again, is the 90%. As I said earlier, really also affordable options if you don't want to build a field and works great in BC climate. It does work in Alberta. Is an air source heat pump. They are very efficient, but they are subject to the ambient temperature of outside, and their efficiency changes drastically as the colder temperature gets colder. Where GeoExchange has this constant ground temperature that as you're down at 70 feet from my wells, that temperature doesn't fluctuate, or fluctuates. You barely would notice it throughout the year for the ground temperature. So the GeoExchange is constant, and generally we are achieving a coefficient of performance of around 4. It's 400% more efficient than your electric energy input that you're putting into it. I just want to show you the difference between, you know, air source heat pump. Why we have the range for an air source heat pump is, as you can see on the performance COP, if it's 70 degrees or 50 degrees outside, we have, you know, a decent COP of that air source heat pump that sits outside. It gives you air conditioning, and they look identical to an air conditioning unit. The only difference is it reverses the cycle to give you heat. And if you're putting an air conditioning into your house right now, put a heat pump in as well. Make it a heat pump, because you can instead of just running your gas furnace, it will give you better coefficient performance through the plus freezing days. But once you hit a certain balance point, it's usually around the freezing point, the coefficient of performance is getting closer to the 1. Where it's getting dropping off. It's still more efficient than the gas furnace, but as we get into colder temperatures and the freezing temperatures, they really don't work as well. They have defrost cycles and everything else that has to go through that starts using energy. Oops, sorry, wrong way. So again, if we look at annual heating costs, I know this is a few years old, 5 years old, and it does change. Obviously with the cost of gas fluctuates up and down. It's been in a hole the last number of years, but it just shows generally this is from a source, Nordic heat pumps, obviously, so they might be a little biased, but we do see that Geo Exchange is the most cost effective or per unit of cost to operate. Now, what did I use? Again, GeoExchange and Spring Creek. I already gave you a little bit of my history and how I ended up in that. This little diagram on the left is the land. It's was 70 acres, 50 acres developable, 20 acres of creek. Build out, it will be 800 to 1,200 residential units. We're on target for about 900 to 1,000 and over 200 hotel rooms. We have currently 500 approximately condos and townhomes built or under construction to date. There's also a 124-room hotel I own called the Malcolm Hotel. And all buildings use some form of GeoExchange. We have been, and they all use an open well system. We have been improving every year. We've been trying to update the first building I built. Everyone had their own heat pump in their unit. So there's 59 units, 59 heat pumps. We went to centralized systems after that. I've been trying to improve that. The reality is these big condo buildings are one big heat source and one big heat sink. We found out cost-wise that the guy on the top floor, he had a big roof. He was a lot more money per square foot to heat his unit. The guy on the first floor was also heating a parquet slab, which was not fair to him because he has this big heat sink that his floor is on top of. These buildings are all one big unit. The guy on the second floor, he only had a little window up front. He had someone top, below, on each side of him. So his heat loss, his unit would never run. So we went to more centralized because it's also more fair and more cost effective to build, and also made more sense long term. So every building we've tried to improve over the construction period, and been at this since 2006. We had about a 4-year slowdown after the recession of 2009 to about 2014 before we really started going again. We were building, but slower, a lot slower rate than one. My goal was always one large building per year. We're back on target for that. The drawing on the left just shows you all the wells that we have drilled for each building. We always have a intake well that we pull the water out, and then downstream from that, because from the top to bottom is the flow, the direction of the water, underground water in Canmore. So highest, the ones more on the top are our intake wells, and the one slightly below that would be our discharge well for the heating system there. We use all 8-inch wells drilled about 70 feet, except for the townhomes. We've done culvert wells that only go down about 10 feet into the water table for the smaller units and single family homes. The middle picture of a couple of our heat pumps. They're just big refrigeration units is what they really are. The newer ones are getting bigger, up to 81 tons. I think these ones might have been 50 tons. We have a big proponent of Built Green. We were the first apartment building at Glacier Rock Lodge in Canada to be certified as Built Green. We started off silver, the next few buildings went to gold, and now we are achieving a platinum with our building design plus our energy savings that we can do with each building by getting our systems more and more fine-tuned. It has been an interesting learning curve in Alberta, as like I said, not a lot of engineers have been involved in this in the past, and not a lot of people and expertise really have done this in Alberta. My current building is Tamerack. We're just pouring this part one of our top slabs today for our commercial building, the building on the foreground right here. That we started out about 6 months ago. This building, it's 81 condo units and 1,500 square feet of commercial. This one, we're my John from Hellbent, who my contractor on this, and Doug from Reinveld and his team. We've really fine-tuned our design and reduced my capital costs by probably 30% on this building from previous buildings. Just we're fine-tuning it every time, and we're getting more and more efficiencies the way we design these buildings and operational costs on these buildings. Just we're really getting good at it. This is from Reinbold, Richard from Reinbold, helped me just put these models together. He does my energy modeling, and this is basically orientation, a Tamerack, and this is what the standard in with Geo Exchange, his numbers ran out to. Shows substantial drop in Geo Exchange for our space heating, our hot water, our quarter pressurization. Some of our miscellaneous equipment's even gone down a little bit. The one area I still disagree with them on, Richard's probably listening, is space cooling. We do have a lot more cooling in our buildings than people know, and that's same with other condo buildings in Canmore that have cooling. Cooling load's probably a lot higher than it's showing there, and there's probably a lot more savings on the cooling load. And the reason for that is, I didn't explain, is in Spring Creek, one huge advantage too by using the groundwater is we do not run that through the Geo Exchange because we have it called free cooling. We can take this groundwater that at 7-10 degrees, bring it right up. We don't have to run it through the compressor. We can run it straight to a plate exchanger and use that as our cooling water for our air conditioning for all our buildings without any compression. It's just running the pump to circulate the water through a plate heat exchanger. It gives us that free cooling, which is a huge cost savings. We don't have to have a huge cooling tower that costs $500,000 and all the operational costs of running these big fans and pumps and maintenance of a cooling tower. But he shows a very low load of space cooling, and I truly believe it's a lot higher, but that's his model pumps out. He's got to run it through the model. And again, this just shows the standard energy use between electricity and gas, and with our building, how we've dropped that down. It's been about a 35% savings in energy consumption just by our mechanical side. Nothing really to do, with our building design as much. So to get into the nitty-gritty costs of construction operation, this has been really interesting. And doing this presentation forced me to actually do a little work I haven't done in a while on what does it cost me to do this with my my VP of construction. Like I said before, we 2 8-inch wells we drill to around 70 feet, one intake, one discharge. With all the geothermal equipment and some extra storage tanks and the heat exchangers and our 2 wells we drill and these large buildings, it's cost me approximately $10,000 extra per condo unit. But if we actually were to compare that to a building that had wanted air conditioning and put a chiller unit in it for air conditioning, that chiller unit would, by the time they install that and put all the piping in for that, it would be cost neutral. It would not going to be much difference in cost because these chiller units for these large buildings are $300,000-$400,000 plus piping, and they'd have to sit outside and they make a ton of noise outside, and let's find a location for them. That we feel we're pretty close to getting close to cost neutral. We started off years ago probably around $20,000 a unit, but we've just been fine tuning it over building by building, getting it to a place where we're very cost effective. The single family homes we built in Spring Creek and some of the townhomes we built, they're a little bit more because they're smaller. They don't have the centralized heat pumps. They have their individual heat pumps. And generally we feel for around a 4,000 square foot house, it's around $20,000 extra costs, or 2 to 3% on that. But what are the operating costs? And that's where we really feel we're compared to other buildings in town. And I got this information from PICA, our local property managers, about 3 or 4 buildings that they operate, condo buildings that are large, that have centralized boilers for heating and hot water and centralized cooling chillers. They're generally running around $2,300 per condo unit per year. Still that's very reasonable. We are running closer to the $1,500 per unit per year. So GeoExchange is operating on about a 35% cost savings, and that's what Richard showed approximately on his energy model as well. But also the advantage is the maintenance cost. GeoExchange in general should not be much different from other mechanical systems. The biggest change is you got the heat pumps. They will, need maintenance. They will need to be replaced in 15, 20 years, just like boilers do. You do need to maintain your exchangers, but the real advantage is you don't have that chiller. We have free cooling in Spring Creek. We're groundwater straight to exchanger, and the groundwater goes right back in to the ground. We don't have a big chiller unit that we have to maintain and operate. So that's a huge benefit, the air conditioning side. So that's Spring Creek. That's how we believed how efficient, and that's been with us. I did want to give a couple other examples. This is from Cohen from Thermal Creek. Cohen, if you're on there, thank you very much for providing me some of these slides. This is from his presentation he did somewhere a number of years ago. That example that he had of a building using GeoExchange and how you can get to net zero. And that really only comes with adding solar and GeoExchange. Those two are remarkable together. And we are considering that on this building and our next building we're designing right now, again with Jeff Domenico from Jeff, you're on there, sorry, forget your company name. Kibia Energy, looking at solar panels potentially on this building as well. We've been fine-tuning our GeoExchange system, but solar and Geo together, I think he's presenting next week, are the cat's meow, especially if you want to get to net zero. Of course, you got to build a very efficient house, and we all still need to continue to work on that. But if you can do GeoExchange and you have the area to be able to do it, and area to build a field and a capital that's not going to be too expensive with the solar, there's going to be capital costs, you can get to a net zero home very efficiently. And those are some of the numbers that he presented to me when he did his presentation. And we don't have any equipment outside, no noisy air conditioning units or gas lines or anything like that we need. That's the beauty of it. It's very clean. It's very safe. You don't have the potential for CO2 emissions in your house. So what are 6 ways building you'll benefit from GeoExchange? Well, there's a return on investment. Some are quicker than others. Our buildings, condo buildings, are almost neutral, as our belief. If we count AC, air conditioning, but even on single-family homes, it's probably under 10 years. Low maintenance, very reliable, pretty simple systems. But the arbor refrigeration units, and like a refrigerator, every 15, 20 years, we'll probably need to replace or rebuild. Similar step in achieving built green and LEEDs. This has really helped us to get to this last building where I said 35% more efficient than the base building. So it's a similar step, and you need those energy levels to be able to get high levels of built green, platinum, and same LEEDs. Corporate responsibility, attracting those people do want to be at least seem green. I'm not sure people pay for green as much as we all think. A lot of talk, but they do. Customers do want to be known as socially conscious about energy efficiency. And reduce operating overhead. If you have you don't have an air conditioning unit outside, you don't have furnaces and boilers. Overhead can also be reduced because operating costs. Let me see, where am I at? So when to consider GeoExchange, when you have predictable energy consumption. So if your type of industry or business, your energy consumption goes up and down, up and down, up and down all the time, you really can't forecast. And that can be for some GeoExchange can be used for anything. And one other business that I know it was used in the past is milk production. Milk comes hot out of the cows, and if you use the GeoExchange to take that heat and heat up the water that the cows drink, they get more production. So there's some businesses that besides heat in the house that you can use GeoExchange. You got to cool the milk anyways, refrigerate it. Why not take that heat and heat up the water? But predictable energy consumption. You need to know how much you consume, so you size it right. But that's for anything. Process that work between 32 degrees and 160. It used to be at 110 to 120 Fahrenheit, but there's new heat pumps that are coming out that can work up to 160 degrees. You need around 50 degree Fahrenheit heat sink or heat source or field. But they are improving all the time and getting larger and more efficient and bigger widths that they can work. It's definitely a lot easier new construction, but as I did with my rec center, retrofit is possible if you have the area for the field and the area in the building to add more equipment. As I said, land area and ground conditions available for the field. And probably the hardest thing in Alberta is having available designers. Doug from Reinbold's been amazing, his team. They've been great there at Reinbold Engineering. Trades, John from Hellbent, he's out of Golden, but he's just been amazing. Best guy I've ever had do geo with me. Cohen from Thermal Creek, his guys too, they're very great technical and they're really good in operation and installation. So having those trades and service technicians that understand and have the knowledge of GeoExchange, there's not a lot in Alberta. We're a gas out province, and we're hooked on gas, and that we need to learn, get more people doing GeoExchange in Alberta. Just a couple quotes from different agencies about geothermal. Again, they still call it geothermal here. It's geothermal GeoExchange. You know that it is known as something, Natural Resource Canada, there's likely to be a larger migrating effect on greenhouse gas emission resulting in global warming impact of buildings from any other current market available single technologies and geothermal heat pumps. And I found that, I honestly believe it, that it's a great product to use in the right place. So pros: reducing energy and reducing heat and cooling energy consumption and greenhouse gas emissions by up to 80%. There's no combustion. That's the nice thing. It's safe, comfortable and even heat. It's steady. You know, heat pumps and stuff can struggle, or air-to-air source heat pumps can struggle in the cold temperatures. This is even heat and cooling. It's been proven that the cities know how to inspect it. Low maintenance, great warranties with a lot of the suppliers now of these heat pumps. The guys that are here have been around for a while. And the nice thing is the efficiencies and the cooling and heating. You can simultaneously, as I said, cool your building while you're heating your hot water for your building. And it's the most cost-effective way to get to net zero. You have no noisy sources outside like an air conditioning or like you do making a lot of noise and pissing off your neighbors. And it's proven technology. It's just not known technology. You know, upfront cons can be a hurdle, and that's the drilling side. If you have to drill, that's obviously a bigger cost than the way I do it. If you got to drill multiple wells than the 2 wells I do, or horizontal or other forms of fields. Low natural gas prices in Alberta sure makes the basic case less attractive. When there was gas, you know, 10 years ago was ridiculous, or 15 years ago ridiculously high. It was definitely made the business case more attractive, but it's still attractive. It's still we still save money. And the space you require for your vertical fields, geology around for the ground for the field can be a con. You got to make sure you have good ground. Like I said, granite's better than gravel, less casing. Just costs. And having the qualified installation service technicians and expertise is, you got to find the right people. I've had bad people. I've had people manage buildings after I turned it over, and they totally messed up the systems. And I have good people working with me now, but I definitely know after we turn it over to these condo boards, major issues after for people that didn't know what they're doing in these geothermal GeoExchange systems. And again, designers, engineers that feel familiar with GeoExchange. There's not a lot of people in Alberta that really know this and know how to do it properly. And licensing requirements, as I said, Alberta environment was a big hurdle before. I think they're there, but it was a big surprise how much money it cost me to teach these guys how to do efficient geothermal, and it doesn't affect the environment. So with that, that's my presentation, and open now, Jody, if we can, to maybe some questions and clarifications if there's any.
Sure. Thanks, Frank. Great presentation. We actually have lots and lots of questions. So I'm going to ask people if they can help me out a little bit. So if you open up your question and answer box, which you can find at the bottom of your screen, you have the capacity to read the questions that have been submitted. And there's a little thumbs up sign at the bottom left-hand corner. If there's any questions in there that you are absolutely burning to get answered, please select the little thumbs up sign, and those with the most votes will go to the top of the list, and we will work from the top of the list down, and we will do our best to fit in as many as possible. So Frank, from Ursula, how does the environment get impacted by the change in creek temperature?
Well, we've been doing two things. Your creek temperature is going to change a million times more by the sun and by the weather outside than it will by groundwater that's 70 feet down. We have done a plume study on that. We had to do that for Alberta Environment, show our impacts, and the plume shows that with about 10 meters, the ground at 70 feet is back to ground temperature. So that's one of the studies we did for Alberta Environment, showing that there would not be any impacts on the groundwater that's 70 feet above us.
Perfect. And is there any potential for contamination from the open loop circulation?
For the open loop circulation, no, because we're just taking water through a heat exchanger. I guess there's always the potential if the heat exchanger were to leak. There could be a potential for that, but we would know right away because we'd have a leak in our system, and we'd probably lose pressure in our system if there's a leak between the two plates. But plate exchangers are very good at keeping the two products separate. So we're just using straight groundwater through the exchanger back into the ground.
And what are some of the challenges presented with a GeoExchange retrofit versus a new build?
The biggest challenge is space, that you have room in a mechanical room to install the GeoExchange tanks and the pumps, the units. So having that mechanical room space, either in the existing building or to build an extension, and land adjacent either for the vertical, horizontal wells or whatever form you're going to build your field in. So it's space. That's probably your biggest challenge. Power requirements is another one, because you use a lot more electricity running these heat pumps than you would natural gas. So making sure you have the right power requirements for that you can upgrade your service if required to run these heat pumps.
And in your opinion, is it easy to retrofit?
Again, every system, every home and everything is different. If you have the space, it's relatively easy. Yeah. You have the space and the power, it's relatively easy. If you don't, it could be a challenge.
Great. And what is the lifespan for the underground piping?
Well, most of the stuff is plastic, so it's probably 50 years. You're probably running any form of plastics.
And what are the expected annual maintenance costs for a GeoExchange system?
Again, it depends on the size of the unit. It's probably not for our buildings. We probably have a guy there twice a year. He does a fall inspection, and he does a spring inspection and setup for about 50 for our big buildings for a couple $1,000s per inspection. Then it's just if there's issues, pumps. The pump goes, then you got a couple $1,000s to get a pump replaced or rebuilt. So, my larger buildings were probably $10,000 or $15,000. We might budget a year. For that, we also in our large buildings we have reserve fund studies for roofs, for everything, plus these heat pumps. 20 years for a heat pump, so they start collecting money in our reserve funds for replacement of these things every so often.
And is using GeoExchange a viable path to attaining carbon neutrality in the future?
As you heard me talk about net zero, 100%. I think this is, one of the only ways that we can, obviously by, reducing the amount of energy required in a building and insulation and how we build is also another big factor. But GeoExchange along with solar is a really amazing way to get to carbon neutral housing.
Are the 10-foot deep culvert wells for your single family homes open or closed loop systems?
You're an open loop system as well.
Great, you're being incredibly efficient getting these questions answered. Thank you, Frank. Are your Spring Creek developments solar ready, or are you adding solar as an additional?
No, they haven't been in the past. We are met with Jeff this year on Tamerack, the one we're building right now, to either look at putting solar on the building right away or solar ready. So planning to do that in all future buildings, at least solar ready, but we're possibly looking at doing solar as well on them right away.
Great. Okay, do heat extract and heat rejected need to balance on an annual basis to maintain the ground temperature? And is it possible to do a residential building in a cold climate?
First, no, they don't have to balance the cooling and the heating side because a lot of buildings don't use air conditioning. So it doesn't have to balance, but as one of the first slides, we have 500 times the amount of energy comes from the sun that we need to heat a house, heat that home in that area that we have. So we have so much heat gain into the ground, and the ground itself is such a huge the earth is such a huge heat mass and heat sink. So they don't have to balance, but we do show in our plumes that it does. The plume does change within about 10 meters from the well of the grounds back to temperature because of the flow of the water through there. And obviously we got heat going out the roof. That's basically exchanging as well. You're taking it out of the ground, but it's coming out of the ground at the surface anyways. We're just coming out of the roof of the building and through the insulation. Yes, you can build a Geo Exchange home and anywhere in Canada. Matter of fact, it will work anywhere in Canada. It's just a question of where your field is and making sure generally that you're below the frost line.
Okay. And you mentioned challenges finding qualified designers and installers. In your opinion, how can capacity be built in the industry? How could the 3 levels of government support you?
I think the biggest thing is we had grants in Alberta and Canada for solar in the past, but they had 0 grants for geothermal GeoExchange. And I think that was a really big mistake. I think both provinces and the Canadian government, if they're doing sustainable grants, it shouldn't be just limited to solar. Solar has its place, but as you saw with the COP4, GeoExchange has a huge place in sustainability. As far as other things, I think just training, technical schools like SAIT and NAIT, making sure that there's people getting into this industry. And obviously, the engineering schools, we learned the refrigeration cycle in engineering, but I don't remember learning about GeoExchange. That was 1985 for me, so I don't know if it was really around that much then. So.
And you mentioned a couple of companies. Would you mind giving them a shout out again so everyone can make a note of who to contact if they're interested in geothermal, GeoExchange?
Yes, Don Mogg from Hellbent. He's based out of Golden. Cohen from Thermal Creek in Calgary, and oh God, KPM Energy. Who's on next week?
KCP Energy.
Yeah. We're listening, he's gonna be mad at me. I forgot. He is amazing solar and does solar throughout the province and based here out of Canmore as well. So I think it's important to have their good trades, good, and know their job and good at helping design all through them. And Doug and his team from Reinbold Engineering have been amazing. They've worked really hard with me to try and fine tune the system after each building. They're learning, we're all learning, we're all getting better, and we're all designing bigger, better buildings. Build out Spring Creek, 11, with the hotel rooms be 1,200 units that are using Geo Exchange, and be one of the largest projects in Canada, I believe, at the end of the day.
Okay, well, thank you, Frank. I'm afraid everyone we have run out of time, but I think we got through most of the questions. And I just would like to ask everybody if as they close out of the webinar, you will be asked to participate in a survey. The Biosphere Institute has been working with Dr. Jill Budefeld, a postdoctoral fellow at University of Alberta, and she's helping us to analyze the effectiveness of these webinars. It can be really difficult to measure learning, and her results will support our capacity as a nonprofit to secure funding and continue doing events such as this into the future. So your participation is really valuable. If you could take the time to complete the survey, it should take about 5 minutes. And if you put your email address in at the end, you'll have the opportunity to be entered to win an Anchor portable solar charger. So thank you everyone for your participation. And as Frank mentioned, next week, we do have Jeff Domenico from KCP Energy talking to you about how solar is a viable solution here in Alberta for businesses, homeowners, and developers. And as always, don't forget to check out our online trade showcase. And I hope we'll see everyone next week. Thank you, Frank, again for your amazing presentation. And thank you everyone for participating. See you soon.
Thank you all for listening. Thank you.
Frank, thank you.